93, but is that the height above ground?
My height is about 30 feet off the ground. It's about as high as I can throw the wire up in the tree.
Okay, well, that makes sense. My antennas have one end of each antenna is in a tree, and the other end's on my tower. But I get the antenna.
Hey, good morning, everybody. Still morning, East Coast time. In the great state of Vermont, the Green Mountain State, it's K1GMM Steve, the Hack in the Shack, and coming to you live from Hurricane Hollow. Hey, Peter, what's up? This is just a quick down and dirty update as to what's going on, everybody. I know there's not many. I think, Peter, you're the only one watching probably. But I was recently made aware that our friend Callum, M0MCX, did a video on a presentation on Delta Loops, a really nice presentation. And I figured I'd expand on that a little bit because I do get, hey, Paul, I do get inundated with correspondence regarding the antenna systems I run here. And there's some things I wanted to expand upon and take it a step further with what Callum did. And just to share a little bit more detailed information. Boy, it's a loaded topic, and it's tough. I don't know if I'm going to be able to get through everything, but I figured I'd do it while I was fresh. And hopefully when people see this, it will make them think yes or no, even, put the nail in the coffin as to whether it would be worth doing or not. Now, I'm listening. What's really interesting is I'm listening to some guys on 7168, and this operator right now, he's in there, and I'll let you hear it. He runs a separate antenna on receive. And he mentioned it's quieter. Well, that is one of the things I was going to discuss because I don't believe Callum even mentioned this. Maybe he did. I don't know. He tends to focus more on the modeling aspect of things. And I'm going to go into the actual seat of the pants. What happens when you run these things in the real world? And this is what I found. Now, this could be very specific to my QTH, which I believe it is. But as you guys know, I live in a very deep hole. A canyon, basically. It is a canyon. There is approximately anywhere from 10 to 20 dB of attenuation in this valley. And I can give you an example. I can drive up the mountain with a 6.5 foot whip on the truck with the 857, and I can work 3,000 to 4,000 mile trips, no problem. I don't even hear those stations down here in this valley. I can work, I've done it. Multiple times. I drive 12 miles north out of the valley, and I'm out of the mountains up towards Rutland, Vermont. And I can't even hear the stations on these big antennas coming out of California, and I can blow right into California, no problem, in the mobile. So the antenna systems I put together here on the property are specific for this QTH. I worked for 3 years virtually every day, including sometimes into 11 or 12 o'clock at night, coming up with an antenna system that would be the most effective here at this QTH. Would they work elsewhere? I'm not sure. You'd have to try it. One, I am a huge fan of full wave loops, and I'll give you the reasons why. All you have to do is listen to Tor, LA4OUA, in Norway. He runs a 4-element Cubex quad. Absolutely eats these stacked Yagis for lunch with a single antenna. And you're probably asking, there's something about the audio on a full wave parasitic loop system. You can screw it up. You can end up with phasing issues if you don't do it right. But you can tell, and there's videos on my YouTube channel of myself working a couple guys over in the UK on 2-element quads on 20 meters. Hands down, the biggest signals I ever hear come out of the UK. Hands down. And they're 2-element quads. That tells you something right there for the same amount of power. So what I'm going to get into, basically, let's just take a delta loop, for example. It's a full wave loop, has a little bit lower gain than a quad. And of course, you've seen video presentations I've done on how to orient them. There's different ways to orient them and feed them, which will produce different angles of radiation and polarization, right? Well, most of us all know that at this point. My loops are fed, they're oriented apex down, fed from the bottom, apex. And what that does is they're horizontally polarized, and they are moderately high angle of radiation. Now I'm talking about a single element delta loop, single element. So I'm just going to talk about that first. Callum, he kind of got me thinking, and I get people ask me questions via email all the time on this stuff, so I figured I'd put the nail in the coffin on this. This is just what I found. Mileage may vary. I always say that. They may not work as well in another QTH. I have a bizarre QTH, okay? So before I get into the single element loops, all my loops are parasitic. However, I did run one as a single element delta loop, and we're going to get into that as well, because Callum mentioned feeding these things. And I'll tell you how I fed it and what it actually did, which was fascinating. Again, I don't have any graphs, but charts and stuff like this. I'm just going off the top of my head from what I remember and what I'm currently I'm experiencing and what I have up right now. So the parasitic loops, I ran, there's a video on my YouTube channel, it's buried in there somewhere, where I was trying to pull out a friend of mine, KC2MKI out in Medina, New York. And I was running a Cobra Senior, which is not a slouch. I know guys that work their, get their DXCC fairly easily on a Cobra. And I couldn't even hear him on the Cobra. And I was flipping back and forth from the parasitic, the 2-element deltas, to the Cobra, and he just disappeared. Now, when I put those when I went parasitic, right, and I instead of using a single element delta, I run 2-element deltas. The minute I did that, oriented exactly the same way, fed from the bottom apex, it changed everything. These antennas turn into absolute monsters. And I will stake my life on this. I went from getting the same signal reports. You've seen it on my videos. I'll get 20, 30 over reports in Europe on a 2-element delta, barefoot, on 100 watts. Now, we all know it takes 6 times the power to get 20 dB, right? They are a formidable weapon, and I'll stake my life on it. Everything that you guys see on my QRZ page is a direct result of those antennas. It's not me. It's those antennas. So in the 20 element, when I first got the 20 meter, not 20 element, 20 meter deltas up, parasitic, those were phased at the time. They are no longer phased. They use open stubs exactly the way the 40 meter loops work. Now, I'd work guys in the UK on very little power, and Europe, and they're running more power, bigger antenna systems, big long boom monobanders, stuff like that. Smoke them on those 2-element loops. Proof is in the pudding. I don't care what the models say. I care what actually happens when I put fire into the wire and how they're receiving. Now, I'm not going to poo-poo modeling at all. That to me is a starting point, but the QTHs are so unique. Everybody's QTH is different. Sometimes they work better in one place than another, and that's just a fact. I've had people contact me and say, "Oh, we tried it and it doesn't work." I'm like, well, there's 2 reasons. One of 2 reasons. Either 99.99% of the time it's user error in the construction. Oh, no, we built it exactly like you did it. And I said, okay, if it's not user error, then it's a QTH. Something about the QTH, I don't know. That's the mystery of antennas and building antennas. So I figured I'd just throw that out there. Andy, good to see you. Paul. So, all right, that being said, what's the advantage, and Callum covered this, what's the advantage of a delta loop over a dipole? On transmit, I'm talking a monoband. I'm not talking a multiband. I'm talking a monoband single element delta. What's the difference between a resonant dipole and a delta, single element delta? Not much. In the real world, not much. Here's where the kicker is. Consistently, full wave loops are 2 to 4 S units. I know that sounds like a lot. 2 to 4 S units quieter over a dipole. Remember, we talked about signal to noise ratio. Signal to noise ratio is a make or break situation at the bottom of the solar cycle. The more signal that you can get in with a lower noise floor only works to your advantage, right? Common sense tells you that. Very, very important to think about when you're designing and working with antenna, getting ready to do an antenna system. What is going to improve that signal to noise ratio? Well, I can tell you, delta loops, hell yeah. They are exponentially quieter than a dipole, way quieter than a vertical. Well, we all know that, right? Even a dipole is quieter than vertical, usually. So that being said, what are the advantages of a delta over a dipole? One, even though they're larger, they're full wave loops, they actually fit in a tighter area, tree to tree or point to point, than a dipole does. In one aspect, see, this is where I completely disagree with Callum, respectfully disagree, because he knows a hell of a lot more than I do about most of this stuff. But this is what I found. When it comes to signal to noise ratio, why in hell would I run a dipole when I could run a delta and have 2 S units lower noise floor? So what? It's the same, very similar on transmit. You're lowering the noise floor. That's huge. The other thing with a vertically hung delta fed apex down is it decouples from the ground very easily. Very easily. Your feed point's at the bottom. My deltas, the 40-meter deltas, are literally, I've run them at different heights because I'm adjusting things sometimes and I reset. They're anywhere from 3 to 6 feet off the ground. Now, the tops of them are like 45 feet off the ground. Okay. So that's kind of one of those things. This is seat of the pants. This is what I've seen with my own eyes. Okay. So talking about the monoband delta. Now, I have always fed my deltas matched, specifically matched monoband. Can you feed them with open wire, bring them to a tuner? Hell yeah, you can do that. Very effective. Can you jam a 4-to-1 on it? Sure. Multiband the living daylights out of it. I have found personally that you can run a 20-meter delta loop with a 4-to-1 on it, and you can actually get it to work pretty darn good on 30 meters. Force it in on 30 with a reasonable amount of efficiency. I ran one. You can get other bands going up as well. Is it as effective and efficient as a directly matched? Hell no, it's not. I can guarantee you it's not. You could put that on a VNA and look at the numbers, and you will not see return loss figures and gain figures equivalent to a monoband directly matched, let's say using a piece of RG11 at 0.85. Like the RG11 I use, the VF is 0.85. Some of the other stuff I use is 0.66 VF. So a quarter wavelength times the velocity factor will give you the matching stub you need to put in. Just barrel it up, man. Put a direct wire it to the feed point, 259 at the other end. You got your 50 ohm feed line. Slam a barrel in there and jack it in. It'll drop right into shape. And you're probably looking at anywhere from 20 to 30 dB return loss. Very efficient. A whole lot of fire coming out of that thing. Very, very little wasted energy. You get a little bit of wasted energy in the 4-to-1. That being said, I wanted to say this. The other thing to consider with these is the pattern. Now, I used to run a hex beam at approximately, the 20 meter element was about 34 feet off the ground. Very, very good DX antenna. One of the best for its size. Don't really understand how it works or why it works, but it is an absolutely amazing antenna. They're tedious, but they're easy to build and cheap to build. I think it cost me $130 to build that antenna. I had 20, 17, 15, and 10 meters on it. And it was a crackerjack. It worked great. As most of you guys know, it was partially mangled in a storm. And that's when I put the 20 meter deltas up. So you take the hex beam, right? And I had a 20 meter delta, single element delta on a pole with spreaders. And the wire went up the side and then it came across the top. And that was over here on the southwest corner of the house. And I had a 4-to-1 on it. And I just used it across multiple bands. If it worked fine. If it didn't, was it as good on 17 meters, 15 meters as a resonant dipole? No, it wasn't. But it worked. Here's the catch. One day, I was working a station down the East Coast. I believe he was in North Carolina, somewhere in there. I was on the hex beam. And I wasn't very strong. I was about an S7 to him, and I was barefoot. And I said, well, hang on a second. Let me switch over to the delta, the monoband delta. And the feed point, I kid you not, was only 12 feet off the ground. It was on a pole. And, 20 meter deltas, full wave loops, they're big. They're big. You could stand in the center of it, and I don't care how tall you are. You can jump up and down. You'll never touch that top wire. They're huge. And I had that thing out there. And I said, well, let me switch over to that. So I hit the Coax relay, the switch, and brought it over to that delta. He says, oh, man. He says, you're like 5 over. He said, much better on that antenna. Considerably more gain on the hex. But at that distance, that delta fed apex down like this. Apex down with a feed point only 12 feet off the ground on a pole with a 4-to-1 on it, smoked that hex beam. And it's because the hex beam, the pattern is just more for DX. So is it worth running an additional antenna? If you have the room, yeah, it is. Especially on 20 meters where you get these situations where you have these 500 to 1,000 mile skips going on. You shoot yourself in the foot oftentimes with a beam. Whereas a single element delta, and even a dipole probably would have been more effective than the hex. I didn't have one up, so I just used the monoband, or the 4-to-1 20 meter delta. So that was really fascinating. So anyways, I'm listening to these guys talking on here, and he's using a 40 meter dipole at only 6 feet off the ground. He says the receive is lower, but the noise floor is lower, much lower than his other antenna he's using for transmit. And I'm thinking, why would you do that? Why wouldn't you just throw up like a delta loop? You got 2 to 4 S units, lower noise floor, and it's all on one antenna. And you got bodacious receive, exponentially better than that freaking dipole 6 feet off the ground. It's 2 to 4 S units quieter, and you've got better transmit. You got a little bit of gain over like a resonant dipole at the appropriate height. Not much, probably unnoticeable, but you kind of see where I'm going. He'd be better off. Now, I say this, maybe the delta wouldn't work as good on transmit for him where he's at. But now we get into parasitic. This is where deltas, full wave loops come to life. You can read, there's a great article online. I think CBIC did it. The difference between, let's say, a dipole and a full wave loop. Now you read that article and you go, meh. It's not even worth doing a full wave loop. Well, maybe not. But I'll tell you, when you put them into a parasitic configuration, the gloves come off, everything changes. Like I said, what took me 700 watts to get us the same signal report in Europe that I get on 100 watts, the difference between a dipole Cobra, 700 watts, I can get the same signal report on 100 watts on the parasitic deltas. So that's, say 2, 3. That's like 3 times the power and change increase just by going to a parasitic delta over like a dipole or a Cobra. That's significant, Johnson. That's like freaking 10 dB of transmit, if you think about it. 10 and change, 12, 13 dB of transmit. Increased punch going to Europe. That's what I'm saying. When you go parasitic on these things, everything changes. The gain is ferocious, and you should see. Well, let me see if I can get this guy on the screen. Now the front to back, because Callum covered this as well. I would not do these. Very rarely will you ever see maximum gain appear at the point of maximum front to back, right? Most of us all know this. So you have to decide, okay, do I want maximum gain or do I want a big back door? Me personally, I don't really care about the big back door. I want maximum fire going in the direction I want it to go, right? So I forgot what I was going to say. So yeah, Callum, that's right. Callum covered this in the modeling. I remember seeing he was looking for a maximum front to back, right? So you should see anywhere from 10 to 15 dB front to back with maximum forward drive. If you're shooting for maximum forward drive on a parasitic loop, pay attention to the front to back, and that will kind of give you an indication. If you're seeing 20 to 30 dB front to back on a 2 element, that's too much. You're not going to see maximum forward drive if you've got 20 to 35 dB front to back on that particular. I don't think so. If you do, I don't know. I'd love to see how you did it, because I'll try it. So let me see if I can get. That's what I was going to say too. So front to back on these things. It depends on the angle at which the signal is coming in. Because on a 2 element, if you look at the pattern of most 2 element loops, even a Moxon rectangle, oftentimes you'll have a lobe that comes off the back side. So let's say your RF is going this way, it's forcing out this way, and you'll have a lobe. You will have a little bit of a lobe, receiving lobe and transmitting lobe off the back, kind of shooting off like this, pretty standard issue. And sometimes signals will sneak in depending on the angle they're coming in at. And this is what I've noticed. So depending on the angle the signal's coming in at, you'll see 15 dB front to back, sometimes only 6 dB, 8 dB front to back. And that's because of the angle, where the signal is coming from into the back of the antenna. Something to watch for. So when you go parasitic, right? Couple ways to do this. Personally, knowing what I know now, I would never put up a delta loop, let's say just for giggles, a 2 element delta loop with a dedicated reflector behind it going in one direction. Knowing how well these things work right now, over the past 5 years, hell no. What a waste that is. So what I would do is I would do 2 identical loops, let's say on 40 meters, space them 20 feet apart, and feed them with exactly, don't question it, just do it, 38.6 feet of quad shield, 75 ohm coax. Don't question it, feed it to a double pole, double throw relay, switch it, and it will go and orient it to the 2 directions you primarily want to go. Now remember, 2 element and beam is not very tight in azimuth. It's got a very broad front lobe, okay? that comes out on the azimuth plane. So it's not like you're using a laser. So it's very forgiving. Like I work people all the time, almost completely broadside to the antenna. It's like this big bulging balloon that comes off, comes off the antenna and it goes out like this. Excuse me. So personally, the way I would do it, and I don't think he covered this in this, is do it the way I do it. Bang for the buck, bang for the time. Force it into a parasitic realm using open stubs to create the loading necessary to make the element that is not directly connected to your feed line, in other words, the part that's connected to your radio, at that time, you want that other element to look electrically longer than it physically is. You want to see roughly 120 ohm inductive load on that element. Boom. That turns it into a reflector. All your well, not all of it, but majority of your RF is spit out in one direction. You want to go the other direction? Piece of cake, flip the switch. Boom. Energizes, it lifts the pin in the shield on the original element that was active, and that loads up as a reflector, and your other element goes active, forcing the RF in the 180 degrees in the other direction. So from the northeastern United States here, I have my antennas oriented northeast to southwest, approximately 53 degrees, puts me into Europe, all the way down into the Middle East, and southwest, which puts me all the way down the eastern seaboard and all the way out to like Texas. Those are like the kill boxes for me. So I figured I'd just throw that stuff at you guys, and I know that's a lot of information probably, but at least I posted it and you can kind of go back through it. When you're thinking about playing with these loops, whether it's a single, whether it's a monoband, whether you're multi-banding it, and give you some stuff to think about. This is all stuff that I found out to be 100% true for my QTH in my situation. Mileage may vary. I have a lot of interaction here. I have a 4,000 foot chunk of marble literally right behind the antenna. Goes straight up like this. Who knows what's going on in this valley? That's why I say mileage may vary. So let me get into the chat here and see if anybody's got. So if a loop is 2 to 4 S units quieter, does it get out better? That first question there, Joseph. Like I said, if you were to look at the pattern, the gain characteristics over let's say you have a dipole on 40 meters, half wavelength off the ground on 40 meters, that's going to need to be what? 65 feet, 70 feet off the ground. Over a delta loop at 45 feet, they'll probably be pretty close on transmit. Probably. The catch is the quietness of the antenna. The receive aspect of it. I can tell you these things receive like nothing else. They are freaking gangbusters. I receive. They are wicked. It's because they're so quiet. They're just very, very quiet, But when I say quiet, see, that's why I wanted to reference that guy on 40 meters as I was listening to. See, he's running a severely compromised antenna to get the quietness, but the signal level is actually much lower than his transmit antenna, but he can hear better because the noise floor is lower because it's down close to the ground. You don't have to do that. You could put up a delta and have bodacious receive or quad or something like that and a much lower noise floor. So could it compare to a beverage? I'll give you another example. I've talked to this guy, Chaz. What the heck is his name? Oh gosh. I can't remember his call sign. His name's Charlie. Everybody calls him Chaz. He's down, I believe, in New Jersey on 80 meters. Now, I'm usually weak to him on the beverage, but it's much quieter. That's why he uses it. And he flipped over to his transmit antenna. It's much noisier, but my signal was like 1.5 S units stronger to him, much stronger. So I was like an S8, S9 to him, and I was like 10 over on the transmit antenna. But because it's so noisy, he hears me better on the beverage. You kind of see where I'm going. If you don't have enough property to run beverages, deltas are fantastic because they give you the best of both worlds. They give you very good transmit. As a parasitic array, they are almost unrivaled. They're absolutely monstrous. Again, like I tell you, those guys that have worked in the UK running right away when they said 2-element quad, I was like, yeah, that freaking makes sense. One, because the audio. Two, the freaking signal is like unreal coming out of there. 2-element, I would never run on 20 meters. I'd never run more than a 2-element quad. I swear to God. Those guys are just, whenever they're in there, there's 2 guys in the UK that run them. I don't know who they are. I can't remember. But they are freaking cracking coming in here. And mine's the same way. Of course, the band has to be cooperating. But, yeah, and you'll see on the videos, I'm on that 2-element delta. At times, I'll be into Eastern Europe. I mean, just gangbusters on practically nothing. 100 to 400 watts is not a lot of power. This guy I was listening to in here, he was running legal limit. And he was only about an S8. So, you got to kind of, that's a murky area because it has a lot to do with band conditions as well. So, Andy, hey, Abimael? I'm sorry, I probably butchered your name, man. Good to see you. John, what's up? Smashing stub. John, if you're referring to making them go parasitic, there's 2 pieces of coax I use that I know for a fact what the velocity factors are. On the 40-meter array, currently I'm running RG6 quad shield. You can get it out of Home Depot. Don't need anything more than that. Work perfectly fine. And that, the build plan I ran off of, the guy's like, don't even pay attention to velocity factor. 38.6 feet. Just cut it. Space them out 20 feet apart. Pull them up so the feed points are at least off the ground. It'll work. And it does. It does. Not rocket science. It's so simple, it's stupid. So that's that. Now, I can tell you RG11, the particular stuff that I use. I will say, guys, if you're going to start playing with matching stubs, if you can't get pay no attention to what you read online. I'm just telling you. This is my experience. I know someone else who's fussing with this stuff. Unless you can get the actual velocity factor off the manufacturer's website, pay no attention to what people tell you online. I'm just telling you, because a lot of these numbers are not right. The difference between a 0.85 and a 0.72 or 0.74 or 0.76, the difference on 80 meters between a 0.85 VF and a 0.66 VF is freaking enormous. That antenna will not tune. It will not snap into shape if that VF is off. Even the difference between 0.74 and 0.66 doesn't sound like a lot, but if you multiply a quarter wavelength on, let's say, 3.790, let's say you're building one for the DX window, times that velocity factor, look at the difference in length for that matching section. Oh yeah, it's huge. There are ways you can measure it. If you have a VNA, an analyzer, measure it. You'll get but it'll save you a lot of headache and heartache, man. Let's see, Joseph. Should a 2-element loop beam have a driven and director or driven and reflector? What an interesting question. Something I've been wanting to play with again. I put up a beam. I think it's on my YouTube channel. It's in there somewhere, I think. It may have been a set of phase dipoles. Now, pay no attention to the matching sections that I have on these antennas, like the phase systems that you see. I have a 70 plus foot long metal roof that's only about 40 feet away from that 80 meter parasitic arrays that I was fussing with. It screwed those antennas up so bad, it's not even funny, dude. And the reason why I know it did, and I wasn't even really thinking about it, I was on Ballon Design's website. They build, come to find out, I was like, oh, check it out. Because I live here, I didn't really think about it that much. If you have any antenna within a metal structure like that, they actually build a Ballon, which is specifically designed to deal with that specific situation. If you don't think that is screwing your antennas up, you're dead wrong. That will make a mess out of your antenna systems, especially any beam antennas. 40 feet on 80 meters, a metal flat surface like that within 40 feet of on that wavelength. Freaking wavelength is it's 270 feet. So anything within 270 feet or even more will have an effect on that antenna system. Period. It just will. So anyways, I was playing with I can't remember what it was. And I had it all foobarred, right? And come to find out, it was a reversible array, right? I was using a relay to switch it back and forth with stubs, and it was running as a director driven, not a driven reflector. So it was running with a director. The element, I was supposed to be going active. Let's say I'm going northeast. I was supposed to be going active on the northeast element and loading the southwest element, turning it into a reflector. Well, I kept looking at it. I go, I know I freaking wired that switch right. And I went out and I flipped the switch and I looked at it and I looked at where the feed lines came into the relay. Well, the freaking southwest element was active, and somehow I had it so screwed up that the northeast element was becoming a director on a 2-element beam. I'll tell you, man, that thing worked freaking good. I ran it like that for a little while. I know there's theory out there. I don't know that much about it, but if you're going to do a 2-element beam, you're better off doing that. Setting it up with a director instead of a reflector. Because in theory, supposedly, don't hold me to this, but I was reading this somewhere a few years ago. I remember this. They said you can actually generate a little bit more gain running a director instead of a reflector. The problem was I did it by accident. And I ended up, straightening it out somewhat. But if you can do that, I would absolutely try that. My shed, hey, Dear Noobs, how you doing, man? Tell them the stub idea is genius. Do you tune the driven element? Regarding the 40 meter, this is how I do it. What is it? 468 divided by frequency times 2 gives you a full wavelength, right? I think. Beware, and I saw this just recently, beware of cutting your antenna long. The reason why I say this is you're better off taking these antennas and forcing them in on a lower frequency. So let's say, let's just take 40 meters, right? Now, this isn't the case with 40 meters. On 80 meters, it got really weird. Really weird when I tried to force it in up higher on the band than where it was cut for. So this happened with 2 different antennas on 80 meters. One was a sky loop with a reflector underneath it, and that was a freaking fire-breathing dragon. Best antenna I've ever had. Horizontal loop, full wave. I think it was about 200 and it was tuned for down in the lower part of 80 meters, down around anywhere from 30, the CW portion up to about 3720, I think it was. It was like 100 kilohertz, a bandwidth I had there. It was down in that region. But forcing that up above like 3,800, I'd get up into the DX window and then go up towards 3,900. What a freaking mess that thing was. That was so screwed up. Almost couldn't load it. Very odd, right? You think, oh yeah, that thing should load up in there, no problem. But it was weird. And that was a direct match. So I can tell you the 40 meter one, just take 140 feet of wire. Don't even question it. 140 feet of wire, 38.6 feet on RG6 quad shield, double pole, double throw relay, 50 ohm line to the shack. Just do it. Don't even question it. Don't ask. I don't understand it because I've tried to figure out the multiples, the wavelength of those stubs to make that antenna do what it does. It's a weird wavelength times VS. I don't know how this guy stumbled upon this, but it is a freak show. Because if you take a quarter wavelength, 1/4 of 140, you get that number, and then you multiply it times 0.66, it does not come out to 38.6 feet. So he's got something figured out there so that you can get 120 ohm inductive load on the parasitic element, turning it into a beam. It's weird, man. I sat there with a piece of paper and a calculator trying to find the friggin' numbers, and it's a freak show. It's almost like a 3/8 wavelength or something like that. It is. It's like a 3/8 wavelength. Run the numbers on that. It's a weirdo. It's a weird one. And it's actually resonant on a portion of 40 meters where you wouldn't even need a tuner. Go figure. You know what I mean? You think it's something to do with the impedance with putting those two elements, identical sizes together, 20 feet apart. I've never measured that's probably what I need to do is measure the actual feed point impedance on one of those without the stubs attached, just with the wire hanging there. You know what I'm saying? I could do that. Well, you could do that. It'll probably give you a good idea as to what the frick is going on with it. So you do not tune just cut the wire lengths, Joseph. Like for my 20 meter one, I just use a full wavelength and I sit that in, where the heck was it? It was cut at 14.225. So I cut 2 loops at 14.225. And believe it or not, I played with this and it's freaking hilarious. I switched it over from phase lines to, wait a minute, exactly 19.3 feet of RG6 quad shield, making that exactly the same as the 40 meter element. So basically I took that 38.6 and just for giggles, I cut it in half, which is 19.3 feet. I stuck a pair of 19.3 foot long stubs on that thing into the relay. Holy crap. Way better than the phase system. Way better. It probably could be better, but I'm like, screw it. I put it on the VNA. It's actually on, it's on my QRZ page, I think. And I think I did I did. When I did that video on my antennas. You'll see the return loss, your figures on that thing. It's freaking phenomenal, man. So, yeah, so my shed has a small metal roof. Should I ground it? 20 feet between element and roof. Depends on which band, dear noobs. I would ground that. The roof? No, it's just going to see the roof there. So let's say you've got a 20 meter antenna system. If it's a beam, I can guarantee you it's seeing the metal there, but the metal may not be quite large enough to really screw it up. 20 feet is a good distance away. It's definitely seeing it there and it's affecting it, but how much, I couldn't tell you, man. 20 feet's not a big roof, you know. 10 through 80 half squarish. 10 through 80. Yeah, I don't know. I don't know. See, it's hard to say, man, because one, I'm not an expert with this stuff. I can just tell you what I know and what I found, and what I've read. That's credible, right? So I know any flat, large metal surface in within a wavelength of any of these antennas will affect them. If you think it won't, you're fooling yourself. Another situation. When I first was playing with 11 meters years ago, I built the first 2-element, just standard Moxon for 11 meters. Well, I wanted to put it up off the roof of the house. It had a metal roof on it. And it was out off the south end on a standoff on a pole. Now, the antenna itself was probably, I would say, once it was on the rotator and on a pole, maybe 6 feet. And an 11-meter Moxon's tiny. That's a small antenna, right? So I was talking to some friends of mine at the time. They were really experienced with it, beams and building beams and all things like ham radio. I wasn't a ham at the time. And I told them what I was doing, and they said, "You can't put that near that metal roof." And I said, "Sure I can." They said, "No, you can't. No, you can't. That is going to screw that antenna up." You know what? In my mind, I called them a bunch of liars, and I put that antenna up there, and I'll never forget that. It was late afternoon, early evening. My wife was out there helping me, and I sent her in, and I said, "Just key it up and tell me what I could not get that antenna tuned. I fussed with that for hours. The next day I said, "You know what? Screw this." I took it, pulled the antenna off, stuck it out on a freaking pole, like a clothesline pole, 10 feet off the ground. That freaking antenna snapped into shape so fast it'd make your head spin. It's like faster than spit. It was right all along. If you build those antennas, excuse me, exactly according to build plan, they just work. There's no tuning required on a Moxon rectangle, period. If you have to tune it, you screwed it up. That one I'll stake my life on. I have built tons of those antennas from 2 meters all the way to 80 meters. Stick to the build model. If you use coated wire, reduce the overall dimensions by 2% starting, because the calculator was created for bare solid core copper. Do not use stainless. That changes everything. You're on your own when you do that. If you build it exactly how they tell you to build it, no tuning required. So that's why I couldn't figure out. I'm like, what the heck's wrong with this thing? I really screwed it up. No, I didn't screw it up. I put it near that freaking metal roof. What a mess. Yeah, so that's it. That's all I got. Hopefully that's, well, let me check. Let me check here really quick. See who's on 175. I'm on 40. Let's see here. And I need to unmute this.
Golf, November, Ocean.
He's not talking long enough. Okay, that's going northeast. So this is going northeast, right? On the array, the 40-meter array. This is towards Europe. I'm going to bring it back stateside here, going southwest. Here we go.
I had some other people in there that I was having problems with.
He's pretty weak. It's typical 40 meters, crap band, sharp QSB.
Way down. My call again.
Okay, this is going northeast towards Europe.
November, Ocean,
Yep, about 10 to 15 dB. That's what you should see. Going back southwest. Boy, he just took a dump, faded right out. Look at this band.
And I did, and
going northeast.
So anyway.
Oh, he's northeast of me.
I'm a multi-LMAC. Mine is the
No, he is southwest. So he's southwest.
What is it? PMR7 receiver.
There's about 10 dB of QSB.
They have 160
right now.
meters on them. Plus the receiver has a broadcast band.
Going northeast.
And the
3,
AF68
2,
and
1.
the PMR8 got rid of one.
Yeah, so he was about a 5 over. S9 plus 5, and he's about an S5, about an S6 right now. Oh, coming back up to S7. So yeah.
Especially mobile. 6 meters.
So yeah, that kind of gives you an idea of what you can expect. So anyways, food for thought. Just thinking out loud and trying to come up with a little bit more information that may help steer you guys. So go back to the beginning of the video where I talk about, is it worth it? Only you could be the judge. All I can tell you is that signal to noise ratio, this is me personally, signal to noise ratio is the biggest factor in any antenna I put up. With the way, look at this 40 meter band. Look at this thing. Look at it. This is 40 meters. Have you ever seen a bigger pile of crap in your entire life? This is what we've been dealing with. Signal to noise ratio is freaking huge, man. Look at that. You got more noise than any signal on the band. It's horrid. And these are big antennas. Big antenna systems. 2-element beam on 40, I should see freaking 20, 30 over signals in there. The best signal's about, what is this? He's running about, let me get back to stateside. So he's about an S8. He's the strongest, an S8 on 40 meters, strongest signal on the band. That tells you everything you need to know about signal to noise ratio. Yes, Joseph, double pole, double throw switch. Hold on a second. Let me grab it. This is something to consider. All right. These are the double pole, double throw switches I use. And they're not as cheap as some. These are about $16. The problem is these are open. Like this cover comes off and you can see like the holes where the connections are made. 2 connections here. This is where your feed line comes in, your 50 ohm. And these 2 connections and these 2 connections are where your stubs come in, right? I just had to deal with this today. This relay, and I'll probably have to go out there again, had a freaking ant's nest in it. They must have been all in behind the relay in here. And I was like, I flipped it and I had no receive on 40 meters. Well, it's because one of the contacts, there must have been ants crawling around in there. When the thing flipped, it smashed the ant, pinched the ant down. I had to spray the thing all out with friggin' electronics cleaner. And you should have seen the ants, hundreds of them, all coming out, going freaking crazy. So I smoked them all, soaked the whole thing down and sprayed the whole thing out. That's the problem with one of these relays. Now, this is an 80 amp relay. This will take some freaking punishment. Is it necessary? If you ran power in this, like let's say a kilowatt, you'll never hurt this thing with a kilowatt of power. No way. There are other relays that I'm looking at because I'm looking at getting away from these and going to a sealed relay. Much, much better option. Plus, all your connections are tighter. Now, they aren't high in amp. I think they're only like 10 amp. Would a 10 amp relay be adequate? I would think so, right? But they're all sealed. That's what you want if it's outside. If you can find one that's sealed, it's a better option than these. These work well, but you're going to have to maintain them. They're a pain in the ass. They really are. And make sure you put it in a cover. Like I have literally a cat litter container pulled down over the top. This thing's mounted on a piece of cutting board, right? And a cat litter on a pole, and the cat litter container goes down underneath it. And then I just have a couple pieces of thin gauge solid core wire, a couple holes drilled, and I just put the tags in the holes and then tie it off to the pole. You know what I'm saying? And it just holds a cover on there. So if the wind blows, you could put it into a box, you know, but if you do that, you've got to seal the connections where the coax will come into the box. And I mean, it's got to be tight. These damn ants, they're so tiny, they will get into just a little pinhole. So that's why I'm like, well, screw it. I can't possibly get the friggin' box tight enough unless I use like a rubber grommet type thing and force the coax, you know what I mean, through these rubber grommets. So it's like totally airtight. It's just too much of a pain in the ass. So I went the path of least resistance. So now I have to deal with maintenance on them off and on. There you go. See you guys later. I'm out of here. Have a super fun day. It freaking never ends, man, does it? It's been a long time since I streamed, and I hope everybody's doing well. We'll catch you all later. Jump in and shoot me an email or something. Let me know how you guys are making out, and I'll be doing some more streaming here coming up. We'll see. I'm just completely blown away by 40 meters. I mean, you know, you guys, I remember a couple years ago, you could get in here on 40 and signals were like 20 over during the day. You know, I could work Pennsylvania on 5 watts at like 10 to 15 over on these antennas. And look at this. I'll tell you what, though, if there was ever a time to be working on antennas, this is the time. We need to all get our stations going we probably got a year or two before things really start coming back. I don't think it'll be coming back. I've been talking to a friend of mine, and he saw the SFI at actually sub 70 like a week ago. One morning he got up, he looked at the SFI, it was like 68. Whatever. Yeah, we got sunspot activity, but I just looked at, hey, you guys check this out. I'll throw this on the screen for Figgles. Shiznicks and Figgles. This is exactly what we're dealing with. Let me pull this up. I just looked at it before I got on the stream. SWPC. Scroll down here. Here you go. This is what we're dealing with. See this? Let's see. 7 days. Let's go out 7 days. Look at that. This is what we're dealing with. Non-stop solar flares. This crushes HF. Absolutely demolishes it. Yeah. That's what we're up against now. So we're into a transition period. If we are, in fact, going to come off the bottom here, which we're still on the bottom, hasn't moved. I would say if we get up over 100 and stay up over 100 for a while, now we're on the uptick.